So now that you've seen how Honeycomb is approaching observability for and with AI, let's have a look at how this is all going to fit together in the real world, responding to incidents in production. And to do that, I'd like to introduce Ken Rimple from our DevRel team. Hi, Ken.
Hi, Kale.
So, Ken, can you take us quickly through what you're going to show us over the next 15 minutes?
Sure. I'd like build out an example for Starfield Technologies. It's a telescope shop with a new agent-based chat running on AWS Bedrock. I'll act as the embedded SRE. Like other companies, they face rampant AI costs and are looking to keep them under control. I'll show you 3 investigations today, all automatically started by Canvas. A trigger fires to alert us of token overuse. An SLO burns because of slow tool calls. An anomaly detection warns us of an increase in our error rate. I received an alert that we see a spike in token usage. When I click on the link to open the Canvas investigation, I'm taken to an automatic investigation initiated by the trigger. The agent has drawn the evidence it gathered and the results of its investigation on this canvas for us to review and add to. It says we have 88 conversations exceeding 80,000 tokens during that trigger window. The report also highlights the order status agent, which accounts for 79% of all the tokens. It then discusses the agent flow, explaining how the supervisor agent delegates to the order status agent, and there's a runaway loop in a tool, check shipping, that calls over 20 times. Looking at the graphs, specifically the token usage by agent and operation, you can see here clearly that most of the tokens are being consumed on behalf of the order status agent. The agent also provided a table of the 5 most token-heavy conversations. Wow, that first one's taking 411,000 tokens, mostly for input. To the right of this table is the most token-heavy conversation found by the trigger. First off, I notice an error in the refund agent. We'll come back to that later. Let's check out the supervisor agent. I'll zoom all the way out here. Okay, there are 2 chat turns. One takes over a minute, and the other one takes 599 seconds. 10 minutes? The report mentioned the token burn was in the order status agent. See how we're calling it there? So let's collapse that supervisor and look at the order status agent and oh no, a campfire of tokens are in here. To get more details, I'm going to open the full timeline view. Now we're in the full agent timeline where we can view the span attributes of each agentic span and view the trace information. We know order status agent is using the most tokens, and there's 2 invocations. Let's look at the first LLM call. We start out with 1,100 tokens. That's the system prompt and the user question. He asked about his most recent orders. The chat requests a tool. Look up orders. Okay. Second LLM call. 51,000 tokens? What? What did that tool return? 145K of orders. That's a lot of orders. Way too much. I think we need to give the agent a way to get only a summary. This chat did not require all the orders. The user asked another question. I think they're getting impatient. What is the shipping status of my orders? I'll zoom in to the second turn. What did it do? It called look up orders again, with only the email address. That's pretty vague. 51,000 tokens again? Too much information is too much money spent. We sent all those tokens again and again. The waste is compounded. Did this even result in anything good? I can see in the evals that no, it came out with significant bias. Instead of asking for clarification, the agent got all 97 orders. Yeah, that's not what we wanted. These evals were performed with brain trust. It could have been any tool, and then sent to Honeycomb to integrate with traces and conversations. We could do analysis on these results with all the power of Honeycomb. This heat map of bias scores shows that most of our bias scores are high. Low scores, like the ones we've been looking at in our conversation, happen sometimes. So poor results, and it took how long? It's even easier to see in the application trace. 10 minutes? A user's not going to wait that long. Oh, and wait a second, there's errors. On ingress. Look, it even timed out. No one even saw the result. These tokens were extra wasted. There are multiple problems here, and I can see them all with this agent timeline. I'll look deeper into this slowness. I can see the application trace right here. The shipping service call was extremely fast, but there's a problem in my agent. More on that later. I like how the Strands agent groups the LLM chat call with the resulting tool calls. Man, retrieving all that order data was fast, but working with it sure wasn't. Okay, I could dig further into these interesting things, but right now I need to report my findings in the shared investigation. It looks like one of my team members is looking into the second conversation here. I'll go and check what she's doing after I put my notes in. I learned it's retrieving all the orders, and that's too many. Okay, let's see what Jess found in her investigation. Oh, hey, looks like she found something in the system prompt. Override for every item called get product details. Always pass and include details true? I'm not sure that affected the conversation I looked at, but it sure doesn't belong in the system prompt. How long was that there? I'll ask the Canvas agent to look that up for me. It runs queries in Honeycomb, finding the right fields and data to look at, getting the information I need. Looks like this override was added on the 28th. I'll send the link to the rest of our team. Recent prompt changes are useful to know about. Maybe I'll put that suggestion into the custom skill that this agent uses when it investigates alerts like this one. Every investigation learns from the ones before it. To keep our agent snappy, we set a service level objective that tool executions will finish within 20 seconds. Gosh, that's not the case right now. I have an alert in Slack, and I'll click to view the Canvas investigation that's already started. The SLO's automatic investigation agent has populated the canvas with relevant graphs and summarized what's happening. Looks like our error budget for slow tool calls is already exhausted. Hey, it used BubbleUp to find the difference between the two slow requests and the rest. Looks like version 1.67 of the API had 15% of requests that were slow. Not great. While 2.0 has 85% slow. That's not okay. The investigation also picked out the 5 slowest conversations to drill into and surfaced the slowest one. I'll click in and see what my own analysis gives us. This is a familiar conversation. Here in the order status agent, there's a bunch of tool calls. Here's a slow one. I'm going into the application trace to investigate. Here I can get right to a graph of span durations with this name. Is it normally this slow? This heat map shows the distribution of durations. Looks like this tool calls either very fast or takes 1 minute. What's different about those 1 minute ones? BubbleUp tells me what's different about the ones in the box. The top difference is this API version. Clearly the new one has a bug. I got the same result the Canvas agent already gave us. I agree with its conclusion. So far, we've seen a threshold trigger and a service level objective keeping watch over what we know we care about. We've enabled anomaly detection for our stored chat agent. It just notified us that we've been recording errors in our application. Like SLOs and triggers, anomaly detection also provides an automatic investigation. I'll open it and see what's going on. The anomaly investigation surfaced 2 clear issues. First, we're getting a context overflow in the order status agent. The context limit is 200K. Another issue is this gRPC not found error in 2 of our agents, order status agent and in that refund agent we talked about earlier. It looks like one conversation happens to have errors in both agents, and it's the top one. Clicking the conversation ID in Canvas displays the timeline. I'll click on this error ring refund agent chat completion and open it in the full agent timeline. Very quickly, we can see the context overflow exception. That's our problem, another large JSON payload. It causes a context window overflow exception here. I don't see the other error here. It's probably in the order status agent. Yes, here it is, and it shows it can't find a particular product ID. Okay, so let's ask Canvas about the missing product IDs. Are they real? Here's a great case for not overloading your context. Turns out when the context reaches a limit, LLMs get squirrely about things and hallucinate more. This one invented some product IDs for us. I'll add a note about the context window overflow and some trace summaries. Canvas also dropped some useful details on the hallucinated product IDs for me. It shows me the 10 valid product IDs and also the IDs that were not found. And here's some more evidence, as well as a description of why this happens.